This is SpaceTime, Series 21, Episode 29. Coming up on SpaceTime, could there be tens of thousands of black holes in the Milky Way centre? Scientists developed the first age map for the heart of the Milky Way. And discovery of the most distant star ever seen. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected a dozen stellar mass black holes orbiting close to the supermassive black hole Sagittarius A star at the centre of the Milky Way Galaxy. The findings, reported in the journal Nature, support a decades-old hypothesis that there should be tens of thousands of stellar mass black holes at the galactic centre. Stellar mass black holes are created when stars far bigger than the Sun reach the end of their lives and explode in powerful stellar blasts known as core collapse supernovae. These events are bright enough to briefly outshine an entire galaxy. Usually, these supernovae produce a super-dense, rapidly spinning stellar remnant called a neutron star, an object more massive than the Sun, but compressed down into a sphere just 25 kilometres wide. In fact, just a teaspoon of neutron star material would weigh billions of tons. However, the story doesn't end there. Stars even more massive than those which form neutron stars can have so much gravity that when they collapse, they go down beyond the neutron star state, instead forming a stellar mass black hole, an object so dense and massive that its escape velocity exceeds the speed of light. And as nothing can travel faster than the speed of light, nothing, not even light, can escape a black hole once it passes a gravitational point of no return around the black hole called an event horizon. Stellar mass black holes can also be formed through the merging of neutron stars with other neutron stars, the merging of smaller stellar mass black holes, or the merging of neutron stars with stellar mass black holes. While the process of forming stellar mass black holes is thought to be somewhat understood, the same can't be said for their more gigantic behemoth counterparts, supermassive black holes. These monsters are found at the centres of most, if not all, galaxies, and are millions to billions of times more massive than their stellar cousins. Astronomers speculate they may be formed by the merging of many stellar mass black holes, or through the collapse of giant clouds of gas during the birth of galaxies. Located some 26.4 thousand light-years from Earth, Sagittarius A star has some 4.3 million times the mass of the Sun. Finding a huge population of stellar mass black holes near Sagittarius A star may help scientists better understand how supermassive black holes are formed. The study's lead author, Chuck Haley from Columbia University, says everything science wants to learn about the way big black holes interact with little black holes can be learnt by studying this distribution. He says the Milky Way is really the only way to study these interactions because we can't see them taking place in other galaxies. For over 2 decades, scientists have been searching unsuccessfully for evidence to support the theory that there are thousands of stellar mass black holes surrounding the supermassive black holes at the centres of large galaxies. Although the Milky Way is about 10,000 light-years across, astronomers have so far only found about 6 stellar mass black holes in the entire galaxy. And science's best models suggest that the galactic centre should contain somewhere between 10 and 20,000 in a region just 6 light-years across. But no one's been able to find that many. Sagittarius A star is surrounded by a halo of gas and dust, providing the perfect breeding ground for the birth of massive stars which would live, die, and could turn into stellar mass black holes. Stellar mass black holes from outside the galactic halo are believed to fall under the influence of Sagittarius A star as they lose their energy, causing them to be pulled towards Sagittarius A star, where they're then held captive by its massive gravitational force. While most of these trapped black holes will remain isolated, some capture and bind to a passing star, forming a stellar binary. Scientists believe there could be a heavy concentration of these isolated and mated black holes in the galactic centre, forming a sort of density cusp which would get more and more crowded as distance to Sagittarius A star decreases. In the past, failed attempts to find evidence of such a cusp have focused on looking for a bright burst of X-ray glow that sometimes occurs in black hole binaries, systems in which 2 black holes are orbiting each other around a common centre of gravity. However, because of the great distance to the galactic centre, these X-ray bursts are only bright enough to be detected maybe once every 100 to 1,000 years. So, instead of looking for these bright X-ray bursts, the authors instead have begun looking for weaker but consistent and detectable X-rays, being emitted when a stellar mass black hole is in a binary system with a low mass star. The authors figure that if they can find black holes in binary systems with low mass stars, and they know what fraction of black holes will be in such systems, they can then scientifically infer the population of isolated black holes out there. So Haley and colleagues turned to archival data from the Chandra X-ray Observatory in order to test their technique. The authors searched for X-ray signatures coming from black hole low-mass stellar binaries in their inactive state, and were able to find 12 within 3 light-years of Sagittarius A star. They then analysed the properties and spatial distribution of the identified binary systems, and extrapolated from their observations that there must be anywhere from 300 to 500 black hole low-mass binaries, and consequently about 10,000 isolated black holes in the area surrounding Sagittarius A star. You're listening to SpaceTime. I'm Stuart Gary. Now, while we're on the subject of our home galaxy, the first large-scale age map of the Milky Way shows that a period of star formation lasting around 4 billion years created the complex stellar bulge at the galaxy's centre. The Milky Way is a spiral galaxy with a bulge at the centre about 1,000 light-years in diameter. This bulge contains about a quarter of the galaxy's total mass of stars. Previous studies have shown that this galactic bulge hosts 2 components. There's a population of metal-poor stars with a spherical distribution and a population of metal-rich stars which form an elongated bar with a sort of twist like an X or a bi-lobed peanut. However, when astronomers analysed the metallicity of stars in the Milky Way's galactic bulge, it produced conflicting results. Now, time for a quick explanation. Astronomers refer to all elements other than hydrogen and helium as metals. The first stars in the universe were made exclusively out of hydrogen and helium, with just a sprinkling of lithium and beryllium. These were the elements which came into existence out of the initial Big Bang which created the universe 13.82 billion years ago. And so all the other elements on the periodic table were first produced in stars, either during their lifetimes or when they died. And as the universe evolved and more stars were formed, synthesizing more and more heavier elements, the amounts of these heavier elements or metals increased. So, by knowing the composition of stars, astronomers can determine their metallicity. Now, astronomers from the European Southern Observatory have analysed the colour, brightness and spectral information on chemistry of individual stars to produce an age map of the Milky Way. The authors used both simulated and observed data for millions of stars from the Triple V infrared survey of the inner Milky Way. They then compared those data with measurements of the metal content of around 6,000 stars across the galaxy's inner bulge, taken through a spectroscopic survey with the European Southern Observatory's Very Large Telescope, the VLT. The findings were presented at the European Week of Astronomy and Space Science in the English city of Liverpool. The authors analysed the colour and brightness of the stars to find those that have just reached the point of exhausting hydrogen fuel burning in their cores, which is a very sensitive age indicator. However, the findings weren't consistent with a purely old Milky Way bulge, instead requiring a star formation process lasting about 4 billion years and starting about 11 billion years ago. That means their younger stars are around 7 billion years old, which is older than some previous studies had suggested. The results are based on the analysis of 3 areas of the Triple V infrared map, which combined make up the largest area studied so far in the Milky Way bulge. In all 3 areas, the findings on the age range of the stars proved to be consistent. Previous studies had suggested that the metal-rich stars in the bar were likely to be the younger stars. While the authors couldn't disentangle which stars belonged to the bar of peanut shape and which were the spheroid component of the data, the results indicate that the Milky Way central bar was already formed about 7 billion years ago, and there was no large amounts of gas inflowing from forming stars along the bar after that time. The ultimate goal of this project is the development of a map showing the stellar formation history of the entire Milky Way bulge. I'm Stuart Gary. You're listening to SpaceTime. Astronomers have identified the most distant star they've ever seen. The star, named MACS J1149 Lenstar 1 and dubbed Icarus, is a spectral type B hot blue supergiant located some 9.34 billion light-years away in the constellation Leo. Astronomers made the chance discovery, reported in the journal Nature Astronomy, while using NASA's Hubble Space Telescope to observe a gravitationally lensed supernova nicknamed Refstal located in the same galaxy. This galaxy is part of the giant MACS J1149-2223 galaxy cluster. Gravitational lensing occurs when a massive foreground object magnifies or bends light from a more distant background object. This allows the background object to be observed just as long as the foreground object remains in the right position. Now, usually the lensing object is a galaxy or galaxy cluster, but in some cases it can also be a star or even a planet. And when it involves these smaller objects, the process is called gravitational microlensing. The gravitational lensing process allows Hubble, and consequently astronomers, to see objects they otherwise wouldn't be able to detect. The process was first predicted by Albert Einstein and is now used to find some of the most distant objects in the universe. The star Icarus is at least 100 times more distant than the next individual star astronomers have been able to study, except that is for when stars explode as supernovae. The observed light from this newly discovered star was emitted when the universe was only about 30% of its current age, about 4.4 billion years after the Big Bang. This discovery, therefore, provides astronomers with new insights into the formation and evolution of stars in the early universe, the constituents of galaxy clusters, and possibly also the very nature of dark matter. The study's lead author, Patrick Kelly from the University of Minnesota, first noticed the star back in April 2016. Like the Refstal supernova explosion, the light from this distant star was gravitationally lensed or magnified, making it visible to Hubble. The detection of the star through Hubble was only possible because the light from the star was magnified some 2,000 times, not only by the total mass of the huge galaxy cluster, but also by another more compact object, about 3 times the mass of the Sun, located within that galaxy cluster itself, providing the effect known as gravitational microlensing. In this case, the microlensing was probably caused either by a star, a neutron star, or a stellar mass black hole. And because of that, the observations will also allow astronomers to study neutron stars and black holes, allowing them to estimate how many of these dark objects could exist within this distant galaxy cluster. Now, because galaxy clusters are among the largest and most massive structures in the universe, learning about their constituents also increases science's knowledge about the overall composition of the universe itself. And this includes additional information about that mysterious substance known as dark matter. Now, if dark matter is at least partially made up of comparatively low-mass black holes as occasionally proposed, scientists should be able to see this in the light curve of Icarus. Now, after the initial discovery, researchers were able to use Hubble a second time to measure the spectra of Icarus. And based on their analyses, they were able to determine that Icarus is a spectral type B blue supergiant. Now, these stars are extremely luminous and surface temperatures between 11,000 and 14,000 degrees Celsius, well over twice as hot as the surface of the Sun. And this wasn't the end of the story. Observations made in October 2016 suddenly showed a second image of the same star. Now, the authors assumed the light from the second image had been deflected by another massive moving object for a long time, basically hiding the image. And only when this massive object moved out of the line of sight was the star visible again. To find out more, Andrew Dunkley speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
Let's talk about this star, Icarus, that Hubble has been used to detect halfway across the universe. We know that because there's a half-mile post that shows us where it is. What's the story?
Actually, it's more like 2/3 of the way across the universe.
Wow.
You're underselling it, Andrew. So it's a star which we see because of this quirk of nature called gravitational
lensing.
Lensing, exactly. So here's the story. Back in 2011, the Hubble Space Telescope took a very, very deep image. That means they concentrated for a long time to gather all the photons of this particular area of the sky. And it's an area that has, in what you might call the foreground, even though it's several billion light years away, a cluster of galaxies. So this cluster of each galaxy with 100 billion stars or something like that, but they're clustered together. There's probably 1,000 of these galaxies So that is an enormous concentration of mass. And what that does is bends the space around it in accordance with Einstein's theory of gravity, what we call general relativity. And in bending the space around it, it acts like a giant telescope and effectively focuses on us, the light from objects behind. And faint galaxies and quasars and things of that sort behind the cluster, instead of being sort of blocked off by it, they're actually magnified by it. You can see these curiously distorted images of very distant galaxies in between the images of the lensing galaxies themselves, the ones that are actually acting as the telescope. So that's the scenario. We've got a cluster of galaxies in the middle ground, you might call it, and then other stuff in the far distance, at a distance of about 9.3 billion light years. And that is the stuff that's being magnified. Now, in 2011, the image that was made of this area of the sky showed nothing but these very distant galaxies looking distorted and, slightly anemic. But then another image taken in 2016 revealed a star where one had not been seen before. And what that's telling us is that it's not an exploding star, Andrew, just to clarify, because supernovae, the exploding stars, you see them across actually greater distances than this because they are so incredibly bright. This is a normal star, albeit a big one. It's probably 100 times the diameter of the sun and is something like 1,000,000 times brighter. Why did it pop into existence? It's just because everything in space is moving, and even at these enormous distances, the movement makes a difference to the actual alignment of the gravitational lens. So as this cluster of galaxies and the distant star behind it, as they very slowly change their relative positions, that changes the magnification factor of the gravitational lens. And suddenly the star comes into range of our telescopes. It's brightened up because of the geometry of the lens.
So 7 years ago, we didn't have a clue about it. 2 years ago, we suddenly can see it.
That's right, in 2016. So that's when these observations were made. We're just seeing the reports of it now. Extraordinary stuff, really. And as you say, it's because the stars and the galaxies have moved relative to one another. The astronomers who are doing this work, who are based at the University of Minnesota and other institutions in the United States, they have given this star the name of Icarus. A guy called Patrick Kelly, he's at Minnesota University, he liked the idea of calling it Warhol. And it's named after, of course, the American artist Andy Warhol, who said that everybody gets their 15 minutes of fame, and this star has its 15 minutes of fame when it is perfectly aligned. But apparently nobody liked that. I quite like it. So it ended up as Icarus. Do you want to know what its proper name is?
Oh, I'd love to. I can't wait.
It's MACS J1149 plus 2223 Lens Star 1. Yeah.
I've forgotten it already.
Yeah, well, so have I. And just to explain, Andrew, that a lot of people think, oh, God, these astronomers, they just pull these numbers randomly out of the air.
They do have a meaning.
Yes, they do. It's a catalogue number, but the numbers mean something because most of those digits in there are actually the position of this object in the sky. It's, the equivalent of latitude and longitude on Earth, something we call right ascension and declination. And that tells anybody who kind of recognizes that exactly where this object is, what part of the sky it's in.
Now, you said it was quite a large star compared to ours. It's a blue supergiant.
It is, that's right.
So does that make it young, middle-aged, getting elderly, Zimmer frame?
This star will never reach Zimmer frame status because a blue supergiant.
Young.
Yeah, it'll live fast, die young. Exactly that. And, it's one of these stars that it is probably maybe even one of a relic of the early universe, because we think that the stars in the very early universe were much bigger than the ones that we see around us now, just because there was so much hydrogen in that early universe and it sort of was all more compressed together than it is now. And that's what the raw material of stars is. So it's 9.3 billion light years away. That means that the universe was something something like 4 billion years old when this star was shining. So it probably isn't one of the first generation of stars. We think they were much earlier. But nevertheless, it's still an example of the giant stars that were more common in the early universe than they are now.
Yeah, and a great discovery. And it prompts the question in my mind as to, is that the limit of Hubble's capability? Seeing 2/3 of the way across the universe is quite an incredible achievement.
To see a star at that distance is absolutely unprecedented. I mean, I can remember when I started my career, I remember when we first saw the first galaxy that was about halfway across the universe. Actually, it's slightly less than that, in fact. And that was almost a miraculous occurrence because the sensitivity of telescopes was getting to the stage where you could actually see these things. But of course, now with the Hubble, we can see individual stars. You remember a galaxy is billions, hundreds of billions of stars. This is one individual star that we're seeing. It just shows the way progress has been made. Your question about whether this is at the limit of the Hubble's detectability is right on the money, because it is. It's right at the extreme end of the sensitivity range of Hubble. And that's why astronomers are keen on Hubble's successor, which for many years now has been called the James Webb Space Telescope. It's named after a former NASA administrator.
Let me guess, his name is James Webb.
You're right on the money. Absolutely. For some years before that, it was called the Next Generation Space Telescope, named after somebody called Next Generation. No. So yeah,
that's okay. There's a kid out there named Metallica, so I wouldn't have actually said you were wrong.
Mr. Next Generation. No, so James Webb, a former NASA administrator, it will almost certainly wind up with a different name when it flies, and that's why it's in the news at the moment, and it's why I'm desperately trying to segue into this topic.
You're doing well.
You're doing well, yeah. It is in the news because it's been delayed again, as you mentioned earlier. We were expecting the James Webb Space Telescope to be launched towards the end of next year, around about next October. But NASA has now pushed that back to no sooner than May 2020. So we're still 2 years away from the James Webb Telescope. It's one of a number of delays. It's kind of understandable why this is happening, Andrew, when you think about what kind of a piece of kit this is. It's a telescope whose main mirror is 6.5 meters in diameter, compared with the Hubble, which is 2.4 meters in diameter. But this mirror is too big. If it was a single piece of glass or glassy material, it would be too big for the payload of anything to carry it up there. And so it's made in a segmented form. Segmented mirrors are actually typical now of some of the biggest astronomical telescopes in the world. You make lots of hexagons smaller than the main mirror. These, I think the hexagons on the James Webb Telescope are about 1.5 meters across. There are 19 of them. But the thing is, this has to reach its station in space, which is not in Earth orbit. It's actually 1.5 million kilometers on the dark side of the Earth. It's on the opposite side of the Earth from the sun. It will sit in the Earth's shadow so that it's not receiving radiation from the sun. It's at a point which is called L2, which is a code name for a stable point in the environment of the Earth, where you can put things and they don't move far away. There are 5 of these, what are called Lagrange points. This is one that is on the opposite side of the sun. There are a number of spacecraft there already, so it's not a world first. But what is difficult is that you're putting it 1.5 million kilometers away and expecting this mirror to unfold like a flower opening its petals, and then the components register to a fraction of the wavelength of light, to 1 nanometer, 1 billionth of a meter, something like that. So it is a big technological ask, and that is why I think NASA is playing safe with all the tests that they're doing to ensure that the James Webb Space Telescope doesn't get out to its station 1.5 million kilometers away and then just go and not do anything.
If you remember rightly, Hubble got up there and couldn't focus. So
indeed, I do. Yeah,
it took a long time to get that sorted out.
But the thing about Hubble was it's in Earth orbit. It's in low Earth orbit. It's about 700 kilometers, if I remember rightly. And that meant that spacecraft could reach it. Space shuttle could go and fix it. With the James Webb, you get one shot at this and that's the end of it.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. The SpaceX Dragon CRS-14 cargo ship has successfully docked with the International Space Station. The capsule's carrying fresh supplies and equipment for the 6 Expedition 55 crew members aboard the orbiting outpost. The Dragon had initially blasted off on a Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Air Force Station in Florida.
T-minus 15 seconds.
Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
Falcon 9 is on its way to delivering the Dragon spacecraft for its 14th commercial resupply services mission. Coming up in about 10 seconds, we have max Q, maximum aerodynamic pressure. That's one of the highest stressed states on the vehicle.
Vehicle is supersonic. Vehicle is experiencing maximum dynamic pressure.
Just passed through max Q. First stage burn will last for about another minute and 10 seconds. As we leave Earth's atmosphere, the exhaust plume gradually expanding. Now coming up in rapid succession, at about T plus 2 minutes and 40 seconds, we'll have MECO, or main engine cutoff, followed by stage separation, followed by ignition of the upper stage engine.
We have MECO. Stage separation. Conduct ignition.
The Falcon 9 first stage used for this mission had previously flown on the CRS-12 mission to the space station, while the Dragon capsule used had previously flown on CRS-8. 38 hours after being launched, the Dragon capsule was grabbed by the space station's robotic arm and attached to the Harmony module's Earth-facing Nadir port. The Dragon is carrying some 2,647 kilograms of food and supplies, as well as scientific equipment to supplement the more than 280 experiments currently underway on station. These include the European Space Agency's Atmospheric Space Interactions Monitor, ASIM. ASIM will study elusive upper atmospheric lightning, known as transient luminous events, mysterious electrical discharges shooting from the top of thunderstorm clouds up to the edge of space. These kilometre-wide blue flashes reach heights of 18 kilometres in altitude and have included pulsating jets reaching over 40 kilometres high. ASIM will also be looking at flashes of high-energy radiation known as terrestrial gamma-ray flashes that are also generated by thunderstorm clouds. The Dragon will remain docked to the space station for about a month while it's being unloaded. It'll then be filled up with completed experiments and equipment for return to Earth. The flight was the 7th SpaceX launch this year, keeping the Hawthorne, California-based company on a 2 launches per month timetable. The next SpaceX launch will be NASA's Transiting Exoplanet Survey satellite TESS, which will also fly from Space Launch Complex 40 at the Cape Canaveral Air Force Base. You're listening to SpaceTime. I'm Stuart Gary. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study claims that many of the viruses infecting people today have evolutionary histories dating back to the first vertebrates and perhaps even further back to the very first animals in existence. The findings, reported in the journal Nature, transform science's understanding of virus evolution. The scientists from the University of Sydney looked for RNA viruses in 186 vertebrate species previously ignored when it came to viral infections. They discovered 214 viruses with their genomic material in RNA rather than DNA in apparently healthy reptiles, amphibians, lungfish, rayfin fish, cartilaginous fish and jawless fish. It's the first time scientists can definitely show that RNA viruses are many millions of years old, and that they've been around ever since the first vertebrates existed. The authors found that fish in particular carry an amazing diversity of viruses, and virtually every type of virus family detected in mammals is also found in fish, even relatives of both Ebola and influenza. The world's largest study of its type has confirmed the link between asthma and childhood bone fractures in boys. The findings, reported in the Journal of Pediatrics and Child Health, show that independent of age, boys with a recent wheeze or who had up to 3 recent wheezy episodes were 30% more likely to fracture a bone than boys who had not experienced a wheeze. The same association was not found in girls, although older girls with asthma did have an increased risk of fracture. The results highlight the need for bone health education for this potentially vulnerable group. There have been new revelations this week that the Facebook privacy scandal is far more extensive than first admitted to. it now seems that well over 87 million people have had their personal details accessed by the British company Cambridge Analytica. While most were in the United States, other users, including people in the UK, Canada and Australia, were also affected. In fact, the Privacy Commission claims well over 311,000 victims were Australian. And while we're on the subject, a new study has found that there may be more benefits to deleting your Facebook account than just protecting your private data. The findings, reported in the Journal of Social Psychology, claims it could also reduce your stress levels. The conclusions are based on a study by scientists at the University of Queensland, which investigated the effects of a short break from Facebook on a person's stress and well-being. Scientists have unravelled the genome of the planet's largest animal, the blue whale. The findings, reported in the journal Science Advances, shows that blue whales and their close relatives have been hybridizing during their evolutionary history and seem to have separated into different species due to the absence of geographical barriers. This phenomenon, called sympatric speciation, is very rare in animals. Blue whales are the giants of the sea, up to 30 metres or 100 feet long and weighing up to 175 tonnes. They're bigger than the biggest dinosaurs that ever existed. They're part of a close genetic group of whales known as rorquals, which also include humpbacks and grey whales. In fact, researchers found that rorquals can mate across emerging species boundaries. Usually, species are assumed to be reproductively isolated because of geographical or genetic barriers inhibiting genetic exchange. It's why, when a donkey and a horse mate, they produce infertile offspring. Apparently, however, this does not apply to cetaceans. For these migratory whales, geographic barriers don't exist in the vastness of the ocean. Instead, some rorquals simply differentiated by inhabiting different ecological niches. Cross-genome analysis now indicates there are apparently no genetic barriers between the species and that there's been gene flow among different rorqual species in the past. And before we go, a quick question. Is eating the world's hottest chili really worth a YouTube video if it sends you to hospital? According to a case study reported in the British Medical Journal, a man in the United States wound up in hospital with so-called thunderclap headache after eating a California Reaper, the world's hottest chili pepper. Immediately after eating it, he started dry heaving, followed by severe neck pain and crushingly painful headaches, each of which last just a few seconds, but continue over a span of several days. The man sought medical help and was screened for neurological conditions before doctors concluded that several arteries in his brain had constricted, leading to the thunderclap headaches. Cayenne pepper has sometimes been linked to sudden constriction of coronary arteries and heart attacks, but doctors say this is the first case of chili peppers being linked to such effects. We're pleased to report the man's symptoms did eventually clear up on their own. You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at SpaceTime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.